Hello class, we're going to take a look at graphical misrepresentations of data. And this can happen when a graph that's trying to represent data is very confusing or actually incorrectly made. Sometimes it's just a mistake, and sometimes it's actually trying to get you to think something other than what the data would actually tell you. Okay, so if we're doing statistics the right way, then statisticians are going to take that data, get the same conclusions more or less. Okay, so burglaries in Minneapolis, we have July through August, 20%. Other months, it says 8%. So what's going on here? It doesn't add up to 100%. So what they're doing apparently is averaging the other months and saying that all the other months on average have 8%. So this is like a single month representation for an average of all the other months, whereas this is the total percentage that happened in July through August. So it's not at all accurate. Okay, so if we did something in this type of format, this other months would extend all the way over here because it represents 80% of the total burglaries. Okay, so bad idea. If we want to be fair, we would produce something like this, where each month has its percentage and we get a total that adds up to 100%. The way math works. So we do see that July is the heaviest month, but August is actually not as bad as September and October, according to this graph. Okay, this example here is, it looks as though there's a huge difference in the tax rate between 2017 and 2018. But if you look at the bottom of this, it starts at 36 and it ends at 40. So there's only 4 percentage points differentiating the top and the bottom. So we can fix that. So what we would need to do instead is start our graph at 0% and top it out with as much space as we need based on the percentage data we're working with. And we can see that yes, there's a difference, but it's much less than our original graph would have indicated. Okay, again, here we have a graph with the number in poverty, but it begins at 30,000, and that's actually in thousands, so 30 million, and then it ends up here. Graphically, it looks like it's more than doubled between 2000 and say 2002, and it looks like maybe it's doubled between say 2006 and maybe 2009. But that's misrepresentative. If we had this on a scale where this starts at 0, then these differences between the peaks would be much smaller. And there are times when people do this, not necessarily trying to confuse anybody, but it does, at least it gives us information about the trend. So if that's our purpose, then something like that might work out. But we do have to draw attention to this aspect of it down here. So we can do that with this symbol here. So, okay, lots of numbers, many more numbers on scale between the 0 and 30,000 than we represent from there on. So something has to draw attention to that gap if your only goal was to just identify a trend. Okay, and a better graph for trying to identify trends is something like this particular here. It's a time series plot of the percentages. They do draw attention, and there's definitely a way to identify a trend. Okay, this one is confusing. Look at a sec. So what we don't know is whether this little dashed part is where the bottom of the graph should be considered, or do we go all the way down to the bottom of the paper towel roll? Okay, now if we're going to do this accurately, then we would have to begin in such a way that 17% means the same thing from here to here as it does from here to here. And the issue comes up when we get to the 41%. So not the best graphs, kind of a cute idea, not the best graph. So we have to fix the vertical scaling. Yeah, here's another one where 14 million participants in the US, and then it dropped down to 12 million. But this graph uh, doesn't really line up with the data numbers here. So we got to come up with a better way to represent the number of players in each of those years. So since it was just a 14% decrease, then the area of this soccer ball should only be like 14% larger than the area of this soccer ball. Okay, so what's a better way to represent that graphic? Well, we could use if we're just set on using soccer balls, and then we could use like each soccer ball represents 1 million participants, and then we can see a better relative comparison between 2010 and 2017. All right, this is it's a pie chart, but it's in 3 dimensions. And so to keep the 3-dimensional look, they have to use like a vanishing point, which means something further away from you should appear smaller. So we're probably getting this college no degree inaccurately based on something close to us, like not a high school graduate. So sometimes, something looks cool and we want to do it, or we have a great idea, but does it really convey the message we want? So if we look at the data, then we can come up with a better plan to convey what's going on at a glance. And that's the whole idea of the descriptive statistic, is just let them look at it at a glance. So of course, if we just did a top-down 2-dimensional, we can see now that the relationship between some college no degree and not a high school graduate is much more understandable. Okay, and here's some guidelines for constructing your good graphics. Take a look at these. So these slides are available to you, so you might want to look at them in more detail. Just wanted to create a quick discussion for you. Have a great day.